Okay, so unfortunately the recording previous انقطع على part B, so we start with part C. In part C, when we add 100 milliliters of H2O and 10 milliliters of HCl, okay? Now, خليني نقول the logic behind this part is not very good. Let's see what the pH of water is, what the pH of HCl, and what the pH after that change will be, and conclude. So part C, you already know that if you have 100 ml of H2O, then the pH equals 7. It's H2O, okay? If you have 10 ml of HCl, which is basically H3O plus, that has a concentration of 0.1 molar, then the pH equals 1. It doesn't matter what the volume is because you know the concentration in this volume. However, when you combine the both of them together, the concentration of H3O plus actually changes. Now it's 0.1 molar times 10 ml اللي هي millimole divided by 110 ml. 110, basically it's 100 from the H2O and 10 from the HCl. You get a value of 9.1 times 10 to the negative 3 mole per liter. The pH, and this is greater than 3.2 times 10 to the power negative 7. So simply the pH is negative log H3O plus, which is equal to 2.04. Now the idea, let's compare it with the HCl solution. Let's compare this pH and this pH. Basically, and this pH and H2O. Basically, when you add a strong acid to water, the pH will change from 7 to 2.04. However, انتبهوا للvalue 7 to 2.04. This is for pure water. When you add the same amount of the acid to a buffer, the pH hardly changes. 4.75, 4.67. When you add the same amount of a base to the buffer, the pH hardly changes. Yani the change is approximately 0.1. However, the change is more than 5 when you add it to pure water. So what can you conclude? You conclude that buffers resist the change in pH. أكيد to a certain degree, to a certain extent, they can resist the change in pH. Very good. Now let's start with number 42. In number 42, calculate the pH of a buffer solution. So we have another buffer solution S, which is 0.2 mole per liter in NH3, 0.2 mole per liter in NH4 plus. Very quickly, we can say that the pH is equal to pKa. Why? Because the acid is equal to the conjugate base, exactly the same, which is equal, what's the pKa given? 9.2. Which is equal to 9.2. Very good. This is solution S. Now, in part B, we add to 100 milliliters of S progressively an aqueous solution of HCl, 0.1. Determine the pH 1. Same work. The volume added is 100 ml. The volume added is 200 ml. So basically, here, they're trying to describe the extent of a buffer. قد ايه البفر بداله active. So let's see part 1 and part 2. In number 42, part B1. We have 100 milliliters of S plus 100 milliliters of HCl. Again, HCl is H3. خلينا نظبط هيدي شوي. Of HCl is basically H3O plus. Okay, H3O plus will react with the base in the buffer, which is NH3. It will react with H3O plus, which is HCl, to give you NH4 plus H2O. Again, do the whole thing. Initially, the volume of NH3 is basically 100 times its concentration 0.2. This is in millimole. This is 100 times 0.1. This is 100 times 0.2. Again, the change. We don't have to do the change all the time, but it's okay. This is 10 millimole. Okay, this is limiting. It will lose 10 millimole. It will gain 10 millimole. At the end, 20 millimole of NH3 minus 10, this is 10 millimole. This is a value of epsilon or absolute or approximately 0. And this is 30 millimole. Now, pH is equal pKa degree 9.2 plus log the base, which is 10, divided by the acid, which is 30. Again, its concentration you have to divide by the total volume, but since the total volume is the same, it cancels from above and below. So the pH is equal to 8.72. From the part A, 9.2. Okay, so it's a drastic change, but it's not too much. Now let's see what happens when in part 2 you add NH3 plus H3O plus NH4 plus H2O. Again, initially كان عندي 20 millimole. This time you add 20 millimole of H3O plus because it's 200 ml times 0.1 and 20 millimole of NH4 plus. Okay, both of them are limiting. This will be a value of epsilon, and 40 millimole. So now what do you have in your solution? In my solution, I only have the weak acid NH4 plus. The pH is determined by NH4 plus, which is the weak acid. So how do you calculate the pH of a weak acid? First of all, you have to find its concentration. NH4 plus is basically 40 millimole divided by the total volume, okay, which is 200 plus 100, that's 300 milliliters. So the concentration is 0.1334 mole per liter أو molarity, okay, molar. The pH of a weak acid is basically half pKa minus half log C. If it's less or equal, then pKa minus 1. So that's half 9.2 minus half log 0.1334. Don't use millimoles here. This is concentration, not moles. If it's less or equal, 9.2 minus 1 is basically 8.2. Okay, and this will give you a value of around 5.0, I think 4, okay, less or equal than 8.2, valid. This is your pH. And this is how you can actually remove the optimal capacity of a buffer. You simply just consume one of its constituents, either the acid or the conjugate base. Just simply consume all of it, neutralize all of it, and you no longer have a buffer. But remember, a buffer exists between the ratio acid to base or base to acid between 0.1 and 10, always. Okay, this is part 2 of B. It's done. C. To the solution obtained in B part 2, which is the weak acid NH4+, we add 3.28 grams of sodium acetate, CH3CO- without changing the volume. Calculate the pH of the solution obtained. Okay, so first of all, let's see what the concentration of CH3CO- in the solution will be. This is part C. CH3COO Na will basically dissolve into CH3COO- plus Na plus. This is a weak base. In the solution, you already had a weak acid. Weak base, weak acid, you can say you have pKa1 plus pKa2 if both of them have the same concentration and similar Ka and Kb. Okay, so it's Ka of the acid and Kb of the base, يعني pKa و pKb. But first, let's check the concentration. So what is the concentration of CH3COO-? It's basically mass, molar mass times the volume. So let's go back to the given just to check what it is. The mass is 3.28, molar mass is 82, and the volume, which is 100 plus 200, that's 300. So 3.28 divided by the molar mass, which is 82, times 300. You have to change to liters home, okay? Because this is why this is grams, gram per mole, okay? And liters. You need mole per liter. You get a value that is approximately equal to 0.1334 mole per liter. Pay attention that the value of the base added is equal to the concentration of the acid present, and the pKa of NH4+ is approximately equal to the pKb of CH3CO-. It means you can say that the pH is equal half pKa of NH4+, which is 9.2, plus pKa of acetic acid, which is 4. Is it given 4.76 or 4.7576, which I don't understand why. Okay, 4.76. And it's equal to basically 6.98. Between the brackets, هنحط إنه هيدول are approximately equal, which is why I can do this. And that is basically number 42, okay? So we already finished 43, 44, 45, 46, 47, 48, 49 is finished, okay? For next time, please solve number 10, number 50, sorry, and 51, 52, 53, 54, and the multiple choice questions till 58 we will do together on Saturday.